So let's remind us what we have learned by now. To create a table in the database, you need to declare a specific class that will be mapped to that table, and you need to have these attributes that will represent each column of the table. And for our IDE, for me it's PyCharm, to understand what the types of the columns for our type hinting, we need to specify the mapped type annotation. This is a Python data type associated with each mapped annotation, which corresponds to each SQL data type. For some columns, we can even just specify like that, mapped int, but not for these when we want to define a specific data type, another one, or a specific constraint like primary key, or a length of a varchar type. This way is also possible to declare our columns. It will work as well without mapped column, but for some columns we need to specify and make it equal to mapped column and providing these arguments, as I said before. So let's see how other columns will look like. Let's type full name, which is mapped string. Again, we specify mapped column, and we are now can be importing varchar, variable character, I suppose it's called. We are importing it from SQL Alchemy, and we providing the length of it. We also can provide a collation, but now we are just specifying the length. Our full name is not nullable, so we can just leave it as it is. Then the username, which is the next column, is just varchar without specifying either that it is null or not null. So it is, according to SQL syntax, this column is nullable. So we need to make this explicit. We are specifying varchar nullable true. As I said, we are providing this argument here. And if I were to type this, nullable, it has a hint from IDE, so it's actually written here as an argument. You can see nullable, and it can accept bool, it can accept schema const, like null unspecified, but we are just making it bool, so boolean. The next column is language code, which is not nullable, which for some reason has length of 255, but I think language code may be much more smaller than that. We can make it like 10 characters, but just for demonstration purposes, doesn't matter, can be 255. It's not nullable. We have all users with language code. Then the next column is created at and referrer ID. The created at column is when the row was created, when the record was created, the user. It is timestamp and it has default value of now. So how we are going to do that in the SQL Alchemy? We are going to create again the created at. It is not string, it is date time, I believe, can be date time. And then we specify that this is a timestamp and not nullable and has a default value. But timestamp we also need to import. By the way, you can see that there are multiple import statements from SQL Alchemy. We can have different dialects for different SQL database systems: MS SQL, MySQL, Oracle, and PostgreSQL. Since we are using Postgres, we can just specify this one, but I don't think it really matters here. And default value. So if we want to set a default value, as I said, on the level of SQL, we need to provide another argument, not named default, but a server default. different default options here: server default, server on update, server insert default. We are using server default here, and we are not going to write it like that. Now we are actually going to import it since it's a function. Func. I press Alt Enter. I will have import from SQL Alchemy. You can see it here from SQL Alchemy func. And there are different functions in SQL, like count, sum, random, cast, etc. We are going to need now, function now, and we run it. We call it here. This way our created at column will be created. And the refer ID, which is a user identifier, we will have a foreign key on another user, another Telegram ID. It works like that. You will have one user which invited another, and this invitation link will contain something like Telegram ID of the first one. So the second user, when it accepts the invitation, it will provide our code, the Telegram ID of the referrer, and we writing it here to the refer ID column. It is as well big int, since our Telegram ID is big int. It's a foreign key, and if it references users table, so it's a self-referencing relationship. And we said if the user who was a referrer was deleted from a database for some reason, we set this column to null. We don't want to delete this user because the one who invited him was deleted from the database. This is not a behavior we want to actually implement. So refer ID mapped int, again, mapped column, and here we specify big integer, but we need to provide an argument or the foreign key. So we are typing foreign key. We import it from the SQL Alchemy. And here we need to specify the name of the table and the column name that we are going to reference. So it will be users, Telegram ID, like it is written here. And we also specify the onDelete constraint or behavior. We can also here, we can see other things like onUpdate and many other arguments. We can look through the sources of the foreign key. And here in the doc string, you can read actually what they mean. Or you can read through the documentation of the SQL Alchemy. So here we can just write as a text set null. For the foreign key, we can specify a column as a Python string, like I've written here. We can specify a column if we want as an object. So I believe it would look like that, user Telegram ID, but since it is self-referencing, I don't think it will work like that. So we are just printing as a string. And be aware that users here is written the same way the table name is written, not the class. And yeah, here we did not specify that this column can be not nullable, so which we want to specify in the SQL Alchemy here. So again, we want to always specify whether it is nullable, and we might not specify if it is not nullable. By the way, since we're using this mapped type annotation thing, sometimes if you want to specify that this column is not nullable, we can also use typing annotation optional, like that, and import it from typing, the Python library typing. And like that. Again, here in language code, we might not specify it. In the username, we can specify as well the optional type of the column, optional, mapped, and then string, like that. And yeah, this is pretty much it. We created a representation of our table. Let me try to format this with black formatter. I have it installed, the plugin black connect, and trigger on code reformat. And it just looks slightly more cleaner. So the Telegram ID, full name, username, language code, created at, referrer ID. So here is our Python representation of our table. And then later we can create an instance of our user and use some columns from it. You can see they are here, full name, and the ID suggests what we can do with it, what methods it has, and it's not just string methods. Also, you can set another type of attributes in our class, which is called relationships. This is not the same thing as a foreign key, like we specified here. This is a relationship construct which creates links between ORM objects. Instead of direct column mappings like we did here by ID, we can provide associations between two ORM classes. So referencing not a referrer ID, but a referrer. Let's type it like that, referrer, and it will look slightly like this, the relationship which we import from SQL Alchemy ORM. We specify user, and then we specify other parameters we want this relationship to have. So later we could use an instance of user and use the referrer, which will be another user, and we can use its attributes if we are going to join these tables. But we are not going to learn about relationship right now. So yeah, in this lesson you have learned how to create a simple table of our user from our raw SQL query, and you can try to create some other tables on your own. And in the next lessons we will learn some more advanced ways of creating multiple tables with Python classes using mixins and typing annotations.